In question 16, a 10-foot chain weighs 25 pounds and hangs from a ceiling. We want to be able to find the work done in lifting the lower end of the chain to the ceiling so that it's level with the upper end. Step number 1, we see that the chain's weight density is 25 pounds per 10 feet, which is equal to 2.5 pounds per foot. Step number 2, the part of the chain x feet below the ceiling, the value of x is going to be in between 5 and 10, has to be lifted 2 times x minus 5 feet. So the work needed to lift the ith subinterval of the chain is 2 times x subscript I minus 5 times 2.5 delta x. And now in step 3, writing this as a Riemann sum, w is going to equal the limit as n approaches infinity, as I is equal to 1 goes to n, of 2 times the ith subinterval of x minus 5 times 2.5 delta x. So now we have our function. We know our lower limit is 5, our upper limit is 10, and now we have our function to find the antiderivative. So we have 2 times 2.5, which becomes 5. We factor that out as a constant. And now we have x minus 5 dx. Finding the antiderivative of those gives us 1/2 x squared minus 5x. And now we need to evaluate it with a lower limit of 5 and an upper limit of 10. So now we get 5 times 50 minus 50 minus 25 over 2 minus 25. We get 0 here. Distribute the sign and we get negative 25 over 2 plus 50 over 2, which is equal to 5 times 25 over 2, which is equal to 62.5 foot-pounds.